Hi everyone, this is your math guru. In this video, we're going to be discussing the nature of a stationary point. If I have the graph of a cubic function as shown, then the stationary point is a critical point where the function is neither increasing nor decreasing. So if I draw a line to show where the function is neither increasing nor decreasing, then I have the derivative equals to 0. So I have dy the x of that function equals to 0. And likewise, I have that below. I have at that point, the first derivative is equal to 0. Note that at that point, where my graph is going from positive to negative, and where I have my stationary point, I call that point the maximum. And if I'm moving from negative to positive, I call that point my minimum. Note that at the maximum point, or at maximum, where my dy dx is equal to 0, my second derivative, that is my dy d squared y over dx squared, the value will be less than 0. And at minimum, my second derivative, my d squared y over dx squared, will be greater than 0. And if I have my second derivative equals to 0, I call that point the point of inflection, where I have my second derivative equals to 0. Note that the second derivative, as shown, is used to test the nature of my stationary point. So if I find my second derivative and the value is less than 0 or negative, then I know it's at maximum. Or if I find my second derivative and the value is greater than 0 or positive, I have that point as my minimum. And if it's equal to 0, that will be my point of inflection. Let's look at it as an example together. If, for example, I have the cubic function y equals 2x cubed plus 3x squared minus 12. To find my stationary point, so if I have stationary point, note that my dy dx will be equal to 0. So in this case, my dy dx equals, I'm going to differentiate my cubic function, and that will give me 6x squared plus 6x minus 12. And remember, to find the stationary point, I need to equate that to 0. So I'm going to solve. I'm going to have my common factor, that's 6 in bracket, x squared plus x minus 2 equals to 0. If I factorize further, I have 6, open my 2 bracket, equals to 0. So I have that as x plus 2, x minus 1. That's me factorizing my trinomial. So therefore, to find the value of x, that will make the equation 0. I have x plus 2 equals to 0. Then x will be equal to negative 2. Or x minus 1 equals to 0. Then x equals to positive 1. So at my stationary point, the value of x is either negative 2 or positive 1. The next step, in order to find the nature of my stationary point, is to find my second derivative. So I've been able to find my first derivative as shown. So from there, my d squared y over dx squared will be, if I differentiate that, 12x plus 6. So to know if my second derivative is positive or negative, I'll start with the first value of x. So I have when x equals negative 2, then my d squared y over dx squared will be, I'm going to replace x with negative 2. So I have 12 times negative 2 plus 6. And that will be 12 times negative 2. That's negative 24 plus 6. So therefore, my d squared y over dx squared is equal to negative 18. And negative 18, this value, means that my d squared y over dx squared has a value less than 0. Therefore, if I go back to my graph, if my dx squared or dy squared over dx squared is less than 0, then therefore that is at maximum. I'm going to do the same for when x is equal to 1. The second one, when x equals to 1, therefore, to find the nature of my stationary point, I have d squared y over dx squared equals, I'm going to substitute 1 into my equation. So I have 12 times 1 plus 6, which is 12 times plus 6. I will give, that is 18. So therefore, my second derivative, d squared y over dx squared, is greater than 0. And once the value is greater than 0, what that means is it's at minimum. That's the nature of the stationary point. Thanks for watching. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. Bye.